This conference will now
So,
be recorded.
in the previous class, we were discussing things with respect to the matrix keypad. So, we saw how to configure the matrix keypad, how to identify which key is being pressed out of all the 12 matrix keypads, and also what happens whenever a matrix keypad, a key of a matrix keypad is pressed. How will you be able to identify that this is the switch being pressed? And also we did see a example of how to identify which switch is being pressed, and we printed which switch is being pressed on the CLCD. And as informed yesterday, today we will first go with a classwork on the matrix keypad in combination with CLCD, and then we will proceed with the next peripheral of the module, which is nothing but ADC. Now to start with, let me first give a small idea of what needs to be displayed, what is the aim of this particular, let's say, classwork. So first we will do that, and then we will proceed with the next peripheral. Now to start with, the thing you have to implement is, let me show you that. Let me directly load the hex file. That will be better. Uh, 16 lab. Okay, give me a second. I will just load the hex file and directly show you the output. Okay, so I hope you can see my screen now. I have the Pixim lab open, and here I am showing you the output of the implementation to be done. First, if you observe on the on the CLCD, you have to display a message. On the very first line, it has to be select matrix keypad switch. And on the second line, it has to say switch 1 for right and switch 2 for left. Okay. So initially on the CLCD, you have to display this message. Select matrix keypad switch. Yes 1 for right and yes 2 for left. Now, if I select switch 1, I'm choosing right. And if I select switch to, I'm choosing left. Now, what does this right and left say is, it is the way you want to scroll the message. So I am going to take a message, and this message has to be scrolled to the right or to the left. Okay, you have to scroll the message to the right or to the left. Now, whenever switch 1 is pressed, I am going to scroll the message to the right. Scroll message to the right. And whenever I press switch 2, I should be scrolling the message to the left. Okay. So I have to scroll the message to the left. So that is the example. You can see here, I'll show by pressing both the switches. First, I press switch 1 of the matrix keypad. So you can see first line says right scrolling and second line says a message being scrolled to the right. Are you able to see? There is a message being scrolled to the right? The right of you. Okay, it is scrolling to the right of you. So if I press switch 1, the message has to be scrolled to the right. So it's like a circular shifting. Whatever goes out here will be coming back on the left hand side. Okay, so it is right scrolling. The moment I press switch 2, I have to achieve left scrolling. You can see the message first, left scrolling, and you can see the message being scrolled to the left. Are you able to observe the output? Are you people there? Okay. So whenever I press switch 1 of the matrix keypad, whenever I press the switch 1, the message has to be scrolled to the right. And if I press switch 2, the message has to be scrolled to the left. So this is what we have to implement. This is an implementation we did in the previous class. I'm just showing an example of how the output should look like. So let us achieve the same. We have to implement the same in case of our program also. Now let us start with the programming part. I hope you got the requirement. There has to be a message which should be scrolling to the right if switch 1 is pressed. A message should be scrolled to the left if switch 2 is pressed. Like digital advertisement boards we are trying to achieve. So something I would say, um, have you seen the nameplates of the buses these days, the city buses? If you stay in Bangalore, we see BMTC buses, or I don't know what is the local transport name is in the other states. So there you can see there will be the name of the destination, okay, and that particular destination's name cannot be displayed in one screen at once. So I may have something to be displayed in a lengthier manner. I have to shift. I have to scroll that particular complete name so that I will be able to display the particular data. So we are going to achieve something similar to that. Okay. So the idea is I have to display the message on the CLCD, and depending on the switch being pressed, the scrolling has to happen. If I press switch 1, scrolling should go to the right. If I press switch 2, scrolling should go to the left. Now let us start beginning with the code. So I'm going to keep this file because I need the driver. Meanwhile, I'm going to create a new project. So file and new project, matrix keypad, then standalone, then clicking on next. I'm going to select the microcontrollers family, which is mid-range 8-bit MCUs. Then the name of the microcontroller, it is PIC16EF877A. That's the name of the microcontroller. Then you have to choose the tool. As of now, we have not been using any tool, so you can skip this, and I'm going to click on next. You have to select the compiler, it's XC8, and clicking on next, I have to give the name of the project. Let me keep the proper name. So I will say CLCD matrix keypad scrolling. Okay. Now generally some of your systems might not allow you to keep this big name. So in that case, if it doesn't allow you to keep this big name, it gives a warning here that the file name is big, that you may have to shorten it. So it gives a warning here at the bottom. But as of now, I am not getting any error or warning in this case. So let me continue. And the name of the project is CLCD matrix keypad scrolling. Then after this, I'm going to click on finish. Okay, so I'm clicking on finish. So after I click on finish, okay, so after I click on finish here, I'll get a new project created. You can see here it is CLCD matrix keypad scrolling. Now for this project, I will be needing the configuration of CLCD as well as matrix keypad. Now I still have my matrix keypad driver open. I have not closed it. So from this itself, I will copy the matrix keypad header file. So Control C. I'm going to paste it under header files of CLCD matrix keypad scrolling. Then source files, I will copy matrix keypad.c, and I have to paste it under source files of the project I have created. Now after this, tell me which CLCD mode should I be choosing, whether it is a 4-bit mode or a 8-bit mode. Which mode of CLCD should we be choosing? Okay, so we have to go for 4-bit mode of CLCD because you already know when matrix keypad is used along with CLCD, matrix keypad will need 4 pins of four pins of port D, that is RD0 to RD4. I cannot use RD0 to RD4, RD0 to RD3. I cannot use it for the CLCD as well. So I should be configuring the CLCD in 4-bit mode. Now to configure the CLCD in 4-bit mode, I'm copying the CLCD.h. Okay. And anyways, in my matrix keypad driver also, I was using the same 4-bit mode. So I'm copying it from the same project. If you want, you can open the driver of 4-bit mode and then copy it. Okay. So I did copy clcd.h and matrix keypad.h. I have copied clcd.c and matrix keypad.c. Now I'm done. I'm going to close this matrix keypad driver project. Now I have to add a source file. So I'm going to the source file, click on new and main.c. Okay. The name of the file is main and extension is C. Name of the file is main and the extension is C. The name of the project, I'm not going to change anything else. I'm going to click on finish. So I will get a main file created. Now the moment main file gets created, I have to do the initialization. So first initialization is with respect to the CLCD. So I'm going to call init CLCD function. Okay. So if you don't remember the name of the function, you can just go to the functions wherever it is available. You can copy the name of the function and paste it. So init CLCD, then I have to do the initialization of matrix keypad. So I'll say init matrix keypad. Okay, let me check the name if it is correct. So yes, init matrix keypad. So I did the initialization of the two peripherals. One is CLCD, the other one is matrix keypad. And I have just added the header files clcd.h and matrix keypad.h. Now when I actually compile this, okay, let me build this and show you what happens. Now first of all, when you are building, you are supposed to get a warning, in fact an error because of linker disagreement. So you have copied a file from one project to another. But apart from that, can you see implicit declaration of init CLCD function? Can you see implicit declaration of, okay, let me show it again. So implicit declaration of init matrix keypad. Can you see this? Two warnings. Now, how do you think I can overcome these two warnings? How to overcome the warnings of init CLCD is first declared, init matrix keypad is first declared? What should I do? Yes, I have to write the prototype of the functions which are already available in the header files clcd.h and matrix keypad.h. So I'm going to directly include the header files. Now the better choice is I will write my own header file. So going to the header files, new and C header file. I create a header file by the name main, extension I'm keeping it as h. Okay, so main.h is the file I'm going to create. Now after this, what happens is I'm going to have let's say in the main.h I'm going to delete all of this and I'm going to include the header file here. Yes, you can have it above main also written. Okay, so that is also fine. Just for the sake of simplicity, just to make sure it is looking simple, I'm having it written like this. So init clcd.h, ash include clcd.h and ash include matrix keypad.h. And let me also include the built-in header here itself, ash include xc.h. Okay, then in the main function I'm going to include main.h. Okay, Okay. So, am I audible? Yeah, I'm sorry. Yes, so we finished including the header files. Now this time the warning has to be gone after you save. Okay, so this warning should be lost. And one more thing, because of linker disagreement, I got an error also. Let me correct that as well. So we have to go to project properties. We have to click on apply and then we have to click on OK. Okay, so after this, let me build this project again and see if I still end up getting any warnings or error. I will see some warnings saying that some functions are not called because we haven't called few of the functions. So that warning will be there. Apart from that, this time I should not be giving any error. Linker disagreement is due to copying. Yes. So that is always because you're copying a file from some other project. You will get some linker disagreement. Okay, so now build has been successful. Now let us complete this project. Now initially to start with, I have to first display a message. First message is, as I said, if you can see here, select matrix keypad switch, yes1 for right and yes2 for left. Now, how many times should I display this message? How many times should I display this message? Only once. Do you think I should write that logic inside a while loop to have that message displayed? Should I have it return inside while? No. So I can write it before while. Now, in order to have a string displayed on the CLCD, which function should I be calling? To have a string displayed on the CLCD, which function should we be calling? Yes, so there is CLCD print function. Now to the CLCD print function, I first specify the string to be displayed. So I'm going to say select matrix keypad switch and make sure you're giving 16 characters in total here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so I'm giving select matrix keypad. Let me give some spaces here and remove some spaces here. So I'm saying select matrix keypad switches. Let me cross check if I have 16 characters. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So I have 16 characters and I'm saying select matrix keypad and I want to display this on line 1 zeroth position. So what should I be passing as an argument to the CLCD print? What should we be passing to the CLCD print? So I should say line 1 zeroth position. Okay, it's a macro line 1 zeroth position. So this will have select matrix keypad switch printed on the very first line. Then on the second line, I have one more message to be displayed. So I will call the same CLCD print function and I will have it said as yes1 for right and space yes2 for left. Okay, so that has to be on line 2 zeroth position. So like this, I will have a message displayed on the CLCD for the very first time. Now after this, if user has pressed switch 1, a message has to be scrolled to the right. If user presses switch 2, a message has to be scrolled to the left. Now to know which switch the user has pressed, I have to read that key. So I take an unsigned character variable called key. Okay, so to read the key from the user. Now I'm going to read the key from the user. Okay, so key is equal to read matrix keypad. Okay, so read matrix keypad. Now tell me whether I have to read it as state detection or level detection. How should we be reading it? Yes, so this time I'm going to read it as a state detection. Just one time I press the switch, a message has to scroll to the right. One time I press the switch, message has to scroll to the left. So I will write it as state. Now, how will I check if I have pressed switch 1 of the matrix keypad? How to check if I have pressed switch 1 of the matrix keypad? So if, okay, key is equal to what? Key is equal to what should I write? Come on. If key is equal to what? What is the read matrix keypad function returning? Yes, that returns the key number. It returns 1, it returns 2, it returns 3, it returns character star, it returns character hash. So should I not check key equal to 1 if to confirm if I have pressed switch 1? Yes. So if I have pressed switch 1, I have to scroll the message to the right. So first, on the very first line, I will see a message called right scrolling. So I'm calling CLCD print function and I say right scrolling. Okay. So right scrolling on line 1, 0th position. Okay. So that is if the key is switch 1. Else, if it is switch 2, if key is equal to 2, then I have to say left scrolling. So CLCD print function, I have to say left scrolling. Okay, so that is again on line 1, 0th position. Are you able to follow this much? Okay, so let me build this and see if this is going to work fine first. Okay, so build is being successful. Let me load the hex file. So here, matrix keypad scrolling, distribute, default, production, the hex file. So first you can see on the very first line, select matrix keypad switch. On the second line, I have given more than 16 characters, which is why it is not completely showing left. So let me anyways correct that. So I have left a space here. If I remove that, it should be fine. You will see that later. Now if I press switch 1, you can see on the first line, it says right scrolling. If I press switch 2, it says left scrolling. Can you see that? I press switch 1, it says right scrolling. I press switch 2, it says left scrolling. Are you able to observe this? Don't look at the second line because I have not implemented the message scrolling yet. So I'm just saying right scrolling or left scrolling. Okay, fine. Now after this, I have to perform right scrolling or left scrolling. I have to take a message. That message has to be scrolled to the right, and I have to take a message which has to be scrolled to the left. Now assume the message I take is CLCD underscore demo underscore code underscore dollar. So I'm taking 16 characters. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. I take a character array called message. Okay. And that is stored with CLCD demo code. Okay. I have to scroll this message to the right. Means after I press switch 1, first, if there is CLCD demo code return like this, okay, so if this is the message, After I scroll to the right, this dollar should go off and it has to come here. So something like this. This will go, and here this dollar will be brought to this place. Okay. Then after some time, it again continues to scroll. So this dollar will go there and enter at the beginning like this. So you are supposed to scroll the message to the right. So again, after some time, one more scroll happens. So something like this, this O will go and it will come to this position. Okay. So it is like this. So this is how you are supposed to perform the scrolling. Are you able to follow this? Okay. Now tell me, how do you make this happen? How do you scroll the message? Reversing the string. Are you seeing the complete reverse of the string? Are you seeing the reversing of the string? Okay, so how to achieve this then? So first initially message will be this. After some time it has to get scrolled like this. After some time it has to get scrolled like this. Index mod by 16y. Okay, now look at this. So I'm writing the position here. I mean index number. So 5, this is 6, this is 7, this is 8, 10, 11, 15. Okay, so this is CLCD underscore demo MO underscore. Okay, position 10, position 11, this is position 12, this is position 13, this is position 14, and there is dollar here which is at the position 15. Okay, then after you rotate it for once, so this C has to go to first position, this L has to go to second position, this D has to go to third position. I'll copy that and write it here. Control. Oh, okay. So this all things gets shifted by one position. Okay, so this will go with C, and here I will end up getting a dollar. So this dollar will be lost. EMO, then underscore, then code. So like this, it has to shift. All of them has to get shifted for once. Are you able to get this? Okay. Now, how will you be able to implement this? How will you be able to implement this? Whatever is in 0th position should go to first position. Whatever is in first position goes to second position. Whatever is in second position goes to third position. So I will run a for loop. Right shift is not possible. Shift operators will shift the bits of a given number. It will not completely shift the data from one index to another. Okay. All right. So I will take a loop. I is equal to 0, j is equal to 0. Okay, Syed is giving me some logic. Let me just copy that. So I'm copying the logic. He's saying for I is equal to 0, j is equal to 0. For j in length of the string, for I till null, temp is equal to message of length minus I. Message of I is equal to message of I plus 1. I plus plus. Message of I is equal to temp. Okay. So what you're saying, message of I is equal to message of I plus 1 is right, but you don't need two loops to perform this. So just a single loop is sufficient. Let me do it like this because I have 16 characters, 16 shifts to be performed. So for I is equal to 0, I lesser than 16, I plus plus. Okay. So here what I have to do is, okay, you are saying message of I is equal to message of I plus 1, right? So it's saying message of I is equal to message of I plus 1. Now if I do it from the beginning, what happens is, first message of I gets assigned with message of I plus 1. Okay. Initially I is 0. Message of I is, I is 0. So message of 0 gets returned with message of I plus 1. So that is L. Okay. Then message of 1 gets returned with message of 2. So that is C. Then message of 2 gets returned with message of C. That is D. So are you not performing left shift here? Are you not scrolling the message to the left? Okay. Can you check and tell me if message of I plus 1 is equal to message of I is the right logic? So do you think message of I plus 1 is equal to message of I will be the right logic? No? What happens if I write message of I plus 1 is equal to message of I? Lokesh, what is that you're typing? Yes. So if I write message of I plus 1 is equal to message of I, the first character will be repeated. Okay. Only first character gets assigned to all of the positions. So I'm going to do it from the reverse order. So I start from 15 index. I is greater than 0. Then I minus minus. Okay. Then I will say message of I is equal to message of I minus 1. So message of 15 takes the value of message of 14. Message of 14 takes the value of message of 13. Message of 13 takes the value of message of 10. So I'm going to do it like this. Okay. Message of 1 takes the value of message of 0. Now if there is a problem, message of 15 will be lost. I'm going to store it into a temporary variable, message of 15, and here I'm going to write message of 0 is equal to 10. Can you check if this logic is going to work fine? Check this. Will this work fine? I asked you to check if this will work fine. Okay. So yes, this has to be working fine. Now let us execute, let us copy this into our project and see if this is going to work fine. Okay. So I'm going to copy this logic under right scrolling. Voice is breaking. Okay. All right. So I take a character variable called temp. So char temp I'm going to take. Then I take a character array called message of size, let's say, I don't have to specify the size anyways. I'll write CLCD demo code underscore dollar. Okay. And I terminate it with a semicolon. Now, after I perform the scroll, so I have to take a variable called I also. After I perform the scroll, I also have to display that message on the CLCD. So I call CLCD print function, and to this CLCD print, I pass the message and let me display it on line to 0th position. Okay, so I'm having the message displayed on line to 0th position. Now let us see what happens. I'm going to save this. I'm going to build this. Okay. So build has been successful. Loading is completed. Let us execute this and see the output. So first, I'll do reload last. Okay. So select matrix keypad switch. Yes, 1 for right and yes, 2 for left. Okay. Now I press switch 1. You can see right scrolling is there. Can you see the message has got scrolled for only once? Can you see the message has got scrolled for only once and now it has stopped. Again, if I press switch 1 more time the scrolling happens. Again, I press switch 1 more time the scrolling is happening. So that is because only when I press the switch, you are going to rotate all of that at once. Only if you press switch 1, you are going to rotate the complete message to the right for once. Now, can you remember and tell me there was an assignment? There was an assignment where you press a particular switch. Yes, you press a particular switch, you see the continuous pattern. Yes, the logic of pre-key, the same you have to apply here also. So, I'm going to take a variable called, one more variable called pre-key here. Okay. So pre-key will be the name of the variable. And here, after I read the switch, what I'll do is, if key is not equal to all released, okay, if key is not equal to all released, then I have to assign a pre-key with the key value. And I have to use pre-key in all of my logic. Okay, so pre-key here and here also it is pre-key. So this time I should be able to see the output. So let me build this. Okay. It got failed. Let me build this again. So sometimes IDE gives a error for unknown reasons. Simply it gave me an error. Now build is successful. So I'll go to the file and do reload last. Now you can see I pressed switch 1. Can you observe the scrolling of the message to the right continuously? Okay. So now it's a part of your homework. I mean, after the class, you're supposed to do for the left shift. So for the left scrolling, the same logic you have to change a little and have it done in the left scrolling. This, in fact, is a part of your assignment. I would say it helps your assignment a little. Okay. So your logic of scrolling a number mark you on SSD. So the same kind of an assignment is this. You have to scroll. Okay. So whatever is the left scrolling is pending, you have to do it by yourself once the class gets over. Okay. So that is your classwork for today. You make sure you're completing this. So this is a hands-on on matrix keypad as well as CLCD combined together. And this is just to show you that you can use multiple peripherals combined with each other. And if one peripheral is using one particular pin, the same pin cannot be used by another peripheral. That is not possible. So you have to take care while choosing the peripherals with respect to the pins of the microcontroller which are being used. So this completes the last but one peripheral of the module, which is nothing but matrix keypad. Any doubts? Okay. So the next we have got is to start with ADC. The next peripheral of the module is ADC. I'll start here we used blocking delay as we are doing only one particular operation, right? Yes. So as of now, my task is just to rotate the message to the right or to the left. So as of now, I don't have much of the functionality to be implemented. Hence, I'm taking blocking delay. But this you can change it with a non-blocking delay also. Input less we can achieve with the digital keypad also. Yes. So that is possible because the number of inputs are less. You can achieve with the digital keypad also. But when it comes to the digital keypad, if I'm not wrong, it uses RB pins. Okay. Now, if you're using digital keypad, you cannot choose a peripheral which needs RB, like the port B pins. Okay. So yes, in that case, CLCD can be used in 8-bit mode also. Correct. So accordingly, you can choose, but you have to take care of the pins wisely. Okay, fine. So we will move to the next peripheral in 5 minutes. Please take a break. Okay. Can we continue? Fine. So proceeding ahead, the next peripheral and the last peripheral of the module is nothing but ADC. So ADC or I would say analog inputs. So we are going to learn how analog input providing devices are taken care of. So far we have been discussing many peripherals, and today it's the last topic of the embedded programming that is going to have the discussion done with respect to the analog inputs. And after this, we are going to start with the communication protocols. Now, if you want your system to deal with a real-time environment, which is changing with respect to the time. For example, if you take temperature, if you take the quality of the soil, if you take humidity, if you take, let's say, something which is changing for time being. Okay, so yes, the speed. So if you have to take action according to the changes which happens rather than the speed which happens in the environment with respect to the time. So speed, acceleration and all that doesn't change with respect to the environment. It doesn't change with respect to the environmental aspects. It changes according to the time, I agree, but not with respect to the real-time environment. Okay, so anything which changes with respect to the real-time environment, then whenever we have to deal with such kind of situation, then we have to make use of a ADC block. Okay, so we need a ADC block. Now, why do you think we need an ADC block is? If you take with respect to the temperature, humidity, the quality of the soil, whatever I gave as an example, generally all of these, yes, moisture, so generally all of this will actually be giving you an analog output. So that rather than a digital output, they are being sensed by the sensors. So sensors senses the things, and generally they are going to give you an analog output. Now, your microcontroller cannot work with the analog input directly. Okay, if you are providing an analog input to the microcontroller, it cannot operate accordingly, because you know that at the end what microcontroller can take is either a 0 or a 1. So what it can take at the end, or what it can understand as a digital signal, or some digital value represented in zeros or ones. Now, if you are giving an analog input to the microcontroller, it definitely cannot take actions accordingly. So I need an intermediate block between the sensor and the microcontroller called as an ADC block, which converts the analog value to a digital value. So ADC is nothing but a functional block which helps us transform the analog signal into a digital value. Okay, and this ADC block can be connected externally at a particular pin of the microcontroller, or some of the microcontrollers will come with the built-in ADC block as well. So depending on the microcontroller you have selected, depending on the built-in components of the microcontroller, you can see whether it has an ADC block which can be used, or if it doesn't have, you have to connect the ADC block externally to a particular pin of the microcontroller. Now, coming to the ADC block, as I said, it converts the analog value to a digital value. Now, there are different types of ADC blocks available in the market these days. So, some of them are listed here. There is flash ADC, there is pipelined ADC, there is SAR ADC, successive approximation resistor. Then there is dual scope ADC, and also there is sigma delta ADC. Am I not audible? Okay. Vinita, please check with your internet once. Yes, I was talking about the types of the ADC. We have flash ADC, pipeline ADC, SAR ADCs, dual scope ADCs, and sigma delta ADCs. Now, if you are preparing yourself for an interview, please make sure you are learning these types of ADCs. You are noting down some of the advantages and disadvantages of each type of ADC. So each type of ADC has its own advantage and disadvantage. You have to note down the advantages and disadvantages of the types of ADC. Okay. So if I have to give, the very commonly used ADC will be the SAR ADC. It's a very commonly used, and some of the people also use sigma delta ADC. So generally SAR ADC is used for data acquisition and sigma delta ADC is used for audio or video control. Okay. So you can like do a small self study. You can refer some documents. You can list down some of the advantages and disadvantages of each type of the ADC. Now, our aim is not to teach you the types of the ADC. Our aim is just to make you understand how ADC is required for our operation and what are the ADC's functionality and how ADCs are going to convert an analog value to a digital value. So that is what we will be discussing about. Now, coming to the next important thing, when we are discussing things with respect to the ADC, we may come across certain terminologies. So, the very commonly heard terminologies are listed here. You come across something called as sampling, there is Nyquist frequency, there is oversampling, there's sampling error, there is quantization, there's aliasing, there is ESNR, resolution. So like this, there are so many terminologies which are associated to the operation of the ADC. Again, I don't want to waste time in explaining each of these terminology because we don't need all of them as of now for our programming part. So how much ever is required for our operation, I'll go with only those many important terminologies. So whichever we don't discuss here, again, do a small self-study later and you should be good to go. You just have to know the definitions of each of them. Now let us discuss on the very most important, very commonly used terminologies in the ADC. So to start with, in our case, what happens is, with respect to the PIC16F877A microcontroller, as I said, if ADC is not available, you may have to connect it externally at a particular pin of the microcontroller. But if ADC is available, we are going to configure the same ADC. Our microcontroller has a built-in ADC, so we are going to configure that particular ADC. Okay, so let us start. The very first important terminology we are going to learn today is nothing but resolution. Now, have you heard of resolution already before this? Do you remember where we learned this resolution? Where was it? In the timers. And what was the resolution representing? What 8 bits? That was the specification. Yes. So width of the timer register was representing the resolution. Somebody's mic is on. Okay. So whenever it is the resolution, okay. So in case of timer, it was the width of the timer register. Resolution was nothing but the width of the timer register. So timer register was having some value stored inside it. So whatever time was counted, its value was stored inside the timer register. So the size of the timer register was considered to be the resolution. Now here also, when it comes to the ADC block, ADC is converting the analog value to the digital value. So it converts an analog value and it gives us a digital value. Now, don't you think I need a memory to store that digital value? Do I not need a special register to store that digital value? Yes. Now, the width of the register I use to have the digital value stored is nothing but the resolution. So I would say width of the ADC register value. Okay. So resolution is width of the ADC registered value. So whatever is the register I have taken to have the digital value stored, so that's the ADC register, and the width of that ADC register is nothing but resolution. Now if the resolution is of 8 bits, how much is the value I can store? If the resolution is of 8 bits, what is the maximum value? Yes, I can store any value ranging from 0 to 255. Now, if the width is of 10 bits, how much? I can store any value ranging from 0 to 1023. So, similarly, if you go with 16 bits, you can store more number of values. As the width of the resolution increases, you can represent more number of values stored inside it. So we call it as states. The digital value what we get inside this ADC register stored, we call it as states. So if there is a 8-bit register, if the width of the ADC register is of 8 bits, then I can store a maximum of 255 states. And if it is of 10 bits, I can represent 1024 states in total. So higher is the resolution, higher is the precision. So more number of resolution you take, more number of states can be represented in the memory block. So resolution is nothing but width of the ADC register. The next important terminology is step size. Okay, so let me show it here. So ADC register width is nothing but resolution. If it is of 8 bits, then it varies from 0 to 255. If it is of 10 bits, it varies from 0 to 1023. If it is of 12 bits, it varies from 0 to 4095. So more the number of bits, more the values can be stored inside the register. Now, I have to convert the analog value to the digital value. That's the task of the ADC. So the next important terminology is step size. Now, step size is nothing but the amount of change in analog value. Okay, so step size is, let me write it down here. Okay, the amount of change, or I would say the least voltage, okay, which changes the digital value by 1. Okay, so I'm trying to put it in as simple words as possible. So step size, as I said, it is the amount of voltage which takes the digital value to change to the next value. So that is nothing but the step size. For example, let's say digital value is 0. The digital value has to go to 1. To get the digital value changed from 0 to 1, whatever the analog voltage it takes is called as the step size. Okay, we can say the minimum change which will be resolved by the ADC is nothing but the step size. Now, in order to calculate the step size, we have a formula which is a very commonly used formula. So, step size is nothing but input range. Okay, step size is nothing but input range divided by 2 power the resolution. Okay, so step size is nothing but input range divided by 2 power the resolution. So if you have to calculate the step size, it is input range divided by 2 power the resolution. Okay, so this is step size. For this much value, the ADC register's value is at least going to change by 1. So let me show it up here. So step size is also called as LSB. It is the minimum change which is resolved. The formula to calculate the step size is input range divided by to power the resolution. The next important terminology is FSR, which stands for full scale resolution. Okay, so it is full scale resolution. So FSR is nothing but the maximum voltage which can be converted to the digital value. Okay, so digital value. So for example, if the resolution is of 8 bits, the maximum digital value is 255. The voltage it takes to get the maximum digital value is nothing but full scale range. Okay, so it is the amplitude of an analog voltage that a ADC can convert to a digital value. Okay, so that is nothing but FSR. So it is nothing but the maximum voltage which can be converted to a digital value. Very simple terminology. It is FSR. The next is the very most important terminology, which is nothing but channel. Okay, the next important terminology is channel. Now, FSR is maximum representable amplitude. Okay, now before I speak about channels, let me have a simple question asked. Assume there is a peripheral which you want to get connected to a microcontroller. What is that interface between the peripheral and the microcontroller called? What is that interface between the peripheral and the microcontroller called? Driver. We have been using it. We have so many peripherals. We have got it connected to our microcontroller. So what is that interface between the peripherals and the microcontroller called as? Nobody remembers that? Buffer. We have known this. We have been using it every single day. There's an interface between the peripherals and the microcontroller pin. Which is that? No, it's not data direction register. You're close to it. What do you mean by ports? Let me show that. Okay. So you can see, I made a statement also. Ports are the interface between the external peripherals and the microcontrollers, isn't it? So don't you think ports are the interfaces or intermediates between the peripherals and the microcontroller? Yes. Now similar to that, when it comes to the sensors, okay, so sensors will be connected to the ADC. Okay, sensors are analog output providing devices. They will be fed to the ADC so that ADC converts that analog value to a digital value. Now, channel is nothing but an interface between sensors. I am writing it as sensors. I can say analog output providing devices, analog output devices and ADC. Okay, an interface between the sensors and the ADC is considered to be a channel. So earlier, if you are dealing with peripherals, the interface between the peripherals and the microcontroller was called as ports. So now we don't call it as ports, even though I use the ADC, which is a part of my microcontroller. So whenever you are going to make use of this particular ADC block, and if there is a sensor connected to the ADC block, remember this peripheral, okay, any sensor being connected to the ADC will have an interface in between, which is called as a channel. The interface between the ADC and the sensors or analog output providing devices are called as channels. So you can observe here, I have multiple sensors on the left hand side. There's a light sensor, there's a temperature sensor, there's a smoke sensor. Then this is the microcontroller. Okay, this square box what you see is a microcontroller. Inside microcontroller, I have a built-in ADC block, which is capable of converting analog value to a digital value. Now this ADC block can have multiple channels. You can see these are the channels through which the sensors can be connected to the ADC. So these are the interfaces between the sensors and the ADC block. Now the point you have to remember is only one channel will be active at a time. Okay, there can be only one channel active at a time. That means if there are multiple sensors, there is only one ADC registered which is used to store the digital value after it is being converted. Now, it cannot take the analog output from multiple devices and convert into a digital value at once. So, what it can do is, it can take the analog output from one sensor, convert it into a digital value, get it stored inside the register. Again, it can take analog value from another sensor, get it converted to a digital value and store it inside the register. So remember, there will only be one channel active at a time. Even though you have multiple channels, there can be only one channel active at a time because it cannot convert all of the analog output to a corresponding digital output at once. That is not possible. So it takes one analog value at once and it converts to a digital value and stores that digital value inside the register. Okay, so that is analog. Is there any doubt? FSR is not clear for me. Okay, Saurabh, I'll repeat that. I was saying FSR is nothing but maximum representable amplitude, which means the maximum of analog voltage which can be converted to a digital value. For example, let's say if it is 5 volts, if I can represent this 5 volt in a digital value and get it stored inside a register, we call it as FSR. So the maximum representable of voltage which can be converted to a digital value is nothing but FSR. Okay, now coming to the channel, as I said, it's an interface between the sensors and the ADC. Only one channel can be active at a time. So whatever ADC is there, it takes the analog input from one channel, it converts into a digital value, gets it stored inside the register. Then it takes the analog input from another channel, get it converted to a digital value, stores it into the same register. That is why, because there is only one because there is only one register, there can be only one channel active at a time. Is it clear with respect to the channel? Okay. Now the next important peripheral associated, important terminology associated to ADC is nothing but acquisition time. Now acquisition time is the time given for the ADC to understand the analog input given to it. Okay, so acquisition time, it's the time given to the ADC to understand the analog input given to it. Okay, so whatever analog input you are going to provide cannot be converted to a digital value immediately. First, the ADC will take its enough time to understand what analog input is being provided to the device. So first ADC block will take its time to analyze what is the analog input provided to it. So the time taken by the ADC to understand the analog input is called as acquisition time. Then we have also something called as conversion time. Now once your ADC block has understood how the signal is, it takes its own time to convert that analog value to a digital value. So that time is called as conversion time. Okay, it's the time taken by the ADC to convert analog value to a digital value. Okay, in fact, after understanding. Okay, so that is nothing but conversion time. The time taken by the ADC to convert the analog value to a digital value after understanding the input is nothing but the conversion time. You can see here acquisition time is nothing but the time taken in order to understand the signal. Conversion time is the time taken to convert the analog signal to a digital signal. So these are the important terminologies associated to the ADC block. Is that clear? Any doubts in this? Okay. Now as you got to know, the ADC is the block which converts the analog value to a digital value. Now there is one peripheral on our board. The peripheral is the potentiometer. So these two are the potentiometers which are available on our board. And these two potentiometers will give an analog value which needs to be converted to a digital value by the ADC which is available on this microcontroller. So this microcontroller comes with a built-in ADC block, and this microcontroller should convert the built-in this ADC block should convert the analog output provided by this pot to a digital value. So we are going to configure this peripheral, which is nothing but the potentiometer. Now, what do you mean by potentiometer in general? So what do you mean by potentiometer? Yes. So potentiometer, we also call it as a variable resistor. Okay. So it's a variable resistor. So potentiometer is also called as a variable resistor. Now what this potentiometer does is, with the help of a variable resistor, it changes the voltage across the load. Okay, it is going to give a different voltage. It gives a different voltage. So according to the way you are tuning the knob. Okay, so potentiometer is also called as variable resistor. So as we vary the knob, resistor is going to get varied. In turn, the voltage is also going to get varied. Okay, so that is nothing but the potentiometer. So we turn the knob, it is going to act as a voltage divider circuit at that particular pin, and it is going to vary the voltage which is being delivered out of it. Now we are going to configure this potentiometer. Okay, we have two potentiometers. We will configure one potentiometer. Now the task of our example is, I have to let's say turn on the LED. Okay, turn on LED if whatever potentiometer value is greater than 2.5 volts. Okay, I will say here I have to configure a potentiometer, okay, a pot, okay. If the pot value is greater than 2.5 volts, I have to turn on the LED. That is my task. And if the voltage provided by the potentiometer is lesser than 2.5 volts, okay, then I have to turn off the LED. So that is my task. If the potentiometer gives a voltage of greater than 2.5 volts when it is tuned, I have to turn on the LED. If potentiometer gives a value which is lesser than 2.5 volts, I should be turning off the LED. Now, do you think your microcontroller will be able to make decisions looking at this analog output of the potentiometer? Do you think it is possible? No. So in between, what do I need to make this work? What do I need to make this work? A comparator? No. So instead of that, don't you think I can work with the ADC block here? So I want this analog value to be converted to a digital value. That's my task. So I have the potentiometer. I have to configure LED. Okay, I have to configure LED. Now, if the potentiometer gives a value greater than 2.5 volts, the LED has to be turned on. And if the potentiometer gives a value lesser than 2.5 volts, then I have to turn the LED off. Okay, so that is what we have to do. When the potentiometer is greater than 2.5 volts, I have to turn on the LED. Lesser than 2.5 volts, I have to turn off the LED. Now, I cannot make decision depending on this analog value. The microcontroller cannot make decisions depending on this analog value. So what I'm supposed to do is, I have to use an ADC block in between. Okay, between the potentiometer and the microcontroller, I have to make use of an ADC block. So for a voltage of 2.5 volts, this ADC gives me a digital value. For a voltage of lesser than 2.5 volts, it gives me an ADC, it gives a digital value. Accordingly, I have to take the action. Is that clear? Okay. Now let us look at the ADC block which is available on our microcontroller. So I am going to take you to the table of contents first. Look at the table of contents and tell which section to be referred. Okay. So which section should be referred? Section number 11, A to D converter. Now if you see here, the analog to digital converter module has 5 inputs for the 28 pin device and 8 for a 40 or 44 pin device. Now tell me, how many inputs will your ADC be able to take with respect to the PIC microcontroller we are studying? With respect to the PIC microcontroller, how many inputs it can take? 33? Yes, it is 8. For a 40 or a 44 pin DIP, so it can take 8 analog inputs. For a 28 pin DIP, it can take 5 analog inputs. So as of now, it's a 40 pin DIP, so it can take 8 analog inputs. Next, the conversion of an analog input signal results in a corresponding 10-bit digital value. How much is the resolution of the ADC register? Yes, it is 10 bits. So resolution of ADC register, okay, resolution here is 10 bits. Now assume the resolution is 10 bits. What is the maximum value I can store? Yes, I can store any value from 0 to 1023. Now assume for 0 volts. Can you tell me what is the ADC value? What is the digital value for 0 volts? It is 0. let's say the maximum is 5 volts. What is the digital value for 5 volts? Digital value for 5 volts. Not with respect to the microcontroller, I am speaking with respect to the ADC block. Okay. For 0 volts, the digital value will be 0. For 5 volts, the digital value will be the maximum value, which is nothing but 1023. Are you able to follow this? So ADC converts an analog value to a digital value. That digital value need not be always a 0 or a 1. Digital value means some integer. Okay. So this ADC will give me a digital value 0 for 0 volts of input. The ADC gives me a digital value of 1023 for 5 volts of input. Now what is it for 2.5 volts? What is the digital value for 2.5 volts ADC might end up giving? Yes, it is 512. Now, can I say if potentiometer gives a value greater than 2.5, your ADC will have a value greater than 512. Can I say that? Okay. Now, if ADC gives a value greater than 512, I can turn on the LED. And if ADC gives a value lesser than 512, I should turn off the LED. So I am rephrasing my statement with the help of ADC. I cannot take action depending on the potentiometer directly. I have to take the help of ADC to get an equivalent digital value. Now, if the ADC gives a value greater than 512, I'm going to turn on the LED. If that is lesser than 512, I'm going to turn off the LED. Are you able to follow this? Okay. Now, that is a rough calculation we made. But if you want to know what digital value is that giving, you can calculate it exactly. For example, let's say I have to first calculate the step size. So we have a formula for the step size. It is nothing but input range divided by 2 power the resolution. Now input range of our microcontroller is maximum is 5 volts and minimum is 0 volts. So 5 volts minus 0 volts. That is the input range divided by 2 power the resolution. So resolution is 10 bits, so 2 power 10. Can you tell me how much is the step size? How much is the step size for this? How much is the step size? 4.8 millivolts. Okay. So I'm going to say 4.88 millivolts. So you can check it later. It gives me 4.88 millivolts. Now, to know the ADC register value, okay, to know the ADC register value, it is nothing but the required voltage, okay, divided by the step size. So I want to know it for 2.5 volts. So 2.5 volts divided by 4.88 millivolts. Okay. So can you tell me how much is the ADC register value? 2.5 volts divided by 4.88. That 0.5. Okay. It is 512.29. But your ADC register can store only a digital value, a whole number. It cannot represent 512.29. So for 2.5 volts, the digital value is 512 in case of 10-bit resolution. So this is what we have to do. If the potentiometer gives a value greater than 2.5 volts, you have to feed it to the ADC, convert it to a digital value. If that digital value is greater than 512, you're going to turn on the LED. And if that digital value is lesser than 512, you're going to turn off the LED. So this is the task we have to be performing. Is that clear? Understood the requirement of the project? Okay. So coming to the implementation of the project, I won't be able to finish it. It will be half done. So the implementation of the project, we will do it in the next class. Okay. So tomorrow we will finish ADC's programming part. And if time permits, we will start with the communication protocol as well. Okay. So remember the requirement to be implemented. We will see the coding part in tomorrow's class. Any doubts in today's class? Okay. Please have your attendance mark before quitting. Here is your QR. Please have your attendance mark. Thanks for attending. We'll continue tomorrow. One second. Okay.